Hi and good day. My name is Yuan Yancey Labay. I'm from ECE32. This project is called Uncovering Critical Factors in Road Traffic Accidents, a multi-model approach. Road traffic accidents, according to the Philippine Statistics Authority, reported a 39% increase in road traffic from 2011 to 2021. So to describe the data that I used, the data was from Mendeley. It was from a study by two people from UP Diliman. They got this from MMDA's database. So what I did to solve those problems that I had, I imputed the missing values and I reduced variables that weren't useful and transformed the time and date and categorized them into respective ranges. For example, for the time, instead of having individual minutes, I divided them into morning, afternoon, evening, and night. So that's from 6 to 12, 12 to 6, again 6 to 12, and 12 to 6 in the morning. As you can see, I one hot encoded some of those as well. I believe combining multiple models to check your dataset produces better outcomes than any one model alone. Again, this is the same code that I use for all 10 models, but in particular, the evaluation metrics that used were accuracy, the precision, the recall, F1 score, and the ROC AUC score. So for the accuracy, as we can see, the 10 models were ranked accordingly. The naive Bayes classifier had the least accuracy out of the 10 models, while the gradient boosting modules model had the highest accuracy out of all the 10 models. So as for the precision, gradient boosting modules down to k nearest neighbors had a precision of 1, which is a good result, while naive Bayes classifier outright failed the precision test. So as for the F1 score, we have gradient boosting modules and decision trees leading the pack, but K nearest neighbors and naive Bayes classifier have both failed the F1 score. So this is a big deal. So that means K nearest neighbors and naive Bayes classifier are not suitable for my dataset, and the rest are doing just fine. And finally, for the area under the curve, GBM and decision trees are leading the pack again. And once again, K nearest neighbors is on the bottom of these 10. So in here, you can see which models are suitable for my dataset. Here are the best and worst visualizations, the GBM and the KNN respectively. So in here, I did feature importance to know which features affect the models the most. So in decision trees, you can see that collision side swipe affect the model the most. In cat boost, it's also the same, but it describes night and partly cloudy night as the weather that affects the prediction the most. So in here, the most important features for each is the rear end collision and the head on collision for gradient boosting module and logistic regression, respectively. So for some models, I didn't run them completely because they were running too slow and they were lagging my laptop a lot, which is not ideal for running a machine learning model. So to conclude, the three models that stood out the best are decision trees, cat boost, and gradient boosting modules, as they have a good score across all evaluation metrics across the board. So based from those feature importance, we can deduce that when it's evening and the weather is partly cloudy, it's night for the lighting, and collisions happen in either head-on or side swipe style, there is most likely a high chance that there will be a fatality in a road traffic accident. So that's my project. My name is Yuan Yancey Labay. Thank you very much for listening to my presentation.